In today's class, actually, we are going to talk about PID, especially PID in DCS. What is the purpose of that? Why we need it? To understand it, it's better to first get into what was before then a PID. So, if you talk about the industry before PID or before automation revolution, this was how the operations were actually held, or operation were going on in industrial automation, or not automation, in process industry, you can say that. So what was happening, like you can see a furnace here. This is a process that need to be controlled. This is a manual controlled procedure. What was happening, there was a gauge, temperature gauge, that displays how much is the temperature inside that furnace, and there was a hand valve here. The purpose of hand valve was to actually control the flame inside that. You can see the flame here. So if you're going to open it up, this hand valve, more flame is getting into. And if you're going to close it based on what's the temperature here, like for example, if temperature is high inside the furnace, looking into the gauge, the person can see and visualize that from here. And based on the value what he's seeing here on the gauge, he is going to decide how much is the opening of the wall, or how much should be the opening of the wall. But this looks not a decent way to control it. There should be some automation involved, and that's where actually PIDs come into the picture. And PID is doing the same job in a perfect and the best way. How it happens, if you can see here, we have, instead of a human, like we need to place a person operator to see and make a decision, and that's a human based decision. Now instead of a human, we adopt a controller specific initially, then eventually we use the DCS and PLC also. For that reason, I would come into that. So what happened, that instead of a gauge, you put in a transmitter is actually connected to controller, and that control this, the current value of the temperature inside the furnace is actually measured by a transmitter, and that's called process value, or PV. So in terms of PID, it's very important to understand PV, set point, CO. So PV is the current process value. For example, the temperature inside the furnace is 40. So this PV would be 40 by, and it would be calculated or sent by transmitter, or measured by a transmitter, and sent it in the form of like 4 to 20 milliamperes to the controller. And controller will see, okay, there is a one set point. Set point is what you want. Like for example, you see here set point is 85, and you can see your PV is 84.9. You understand here? So if PV is 84.9 and your set point is actually 85, set point, like you want your temperature to be 85. You're instructing to this system, I want this temperature to be 85. So this is your set point, and the PV here is 84.9. So now there is a difference. How much is the difference? Just 0.1. So similarly, it is possible, like for example, your PV in the plant, or your temperature value is 50, for instance, and your set point is 85. Based on the difference of set point and your PV, what we call it actually, how much is the difference between set point and PV, is called error. So based on error, actually, your controller is going to send a CO, a control output signal, to control wall. It's going to send that CO signal to control wall, and control wall will, based on what is decided by a controller, how much is need to be open to maintain that set point value as a PV value. So that would be actually regulated by CO, and CO is going to be connected to control wall, and based on what you are going to instruct, control wall open or closed based on need of the process. So now instead of this guy, like controller, this is a hard based controller that exists in industry so far, but now eventually it's replaced by PLCs and DCS. So PLCs and DCS have its own PID blocks in that. So you can also use that PID blocks. So there is a flow meter you can see here. That is actually, this is one of the another example to understand the PID concept. So this is a water flow, and there's a control valve that regulates the amount of water to get in, and this is a flow meter. So this is the flow meter here, and you put up a value of 3.5. You want that flow meter or flow to be 3.5, and then you can see here in this scenario your PV is also 3.5. PV is actually
Mm-hmm.
this 3.5 value here. So it's a very simple closed loop mechanism. This flow meter, flow transmitter, is going to be connected to a DCS. This is a DeltaV DCS. So this guy need to be connected to the analog input module of a DCS system. Okay.
Okay.
If you see in a real industrial environment, then this flow meter need to be connected to a DCS analog input module, and then now there's a PID block inside that processor of a DCS that would regulate that, and we will show you in coming sessions like how to actually make a PID block in a DCS. But for now, you understand that this guy need to be connected to the DCS, and inside the DCS there is a PID block, and PID block would be having a set point, a PV, and also some other like PIND terms, which are some algorithms. We will talk about that in details. How to actually select PID. There are different methods for the tuning of PID loops. But for now, you have to understand that this is straightforward flow meter, and flow meter is connected to your DCS system. And then that guy have an analog output module also, based on the what is the decision, like that control output or that OP value, output value, would be sent from a PID loop inside the DCS, and PID loop was actually the output of PID loop would be sent to the analog output module, and that would be connected to the control valve. So like for instance, the value here is 3.4 or 3. That means there is a difference between set point and PV. What would happen? If there is a less flow here, the control valve need to be opened more. You understand, to meet the requirement of your set point. So that's the way you are going to make a flow PID loop inside a DeltaV DCS or any control system that exists in market. So there are two ways. One way is you have a controller and you're trying to get a data by you are trying to regulate your process parameter based on hardware controller. One way is to use a PLC or DCS control block PIDs to do the same job. So in this example, you can see we are controlling the flow at the specified value by controlling the position of control valve using inbuilt function of DCS. So
Mm-hmm.
this is a typical arrangement, what you see in a plant. There's a plant process, and there is a one value that you want set point, and there is a one value, this is set point. You can see RT is your set point, and this is a process variable, a PV value, and the difference of that actually PV and set point is actually error. How much you are deviating from the set point value, that's error. And that error would need to be passed through the PID algorithm, which are three terms, P, I, and D, we would be talking about in details about that, and how to tune a PID loop. This is the very, very important thing to understand. So P, I, and D. So it would pass through this PID, you can say block, that consists of three terms in that, and there would be a tuning tips and tricks that we are going to actually talk about in detail. But for now, you just understand P, I, and D. They actually, this PID block would actually decide how much need to be actually regulated, how much control valve need to be open in the case of flow control that you see in a previous example. So you see, you have a desired state and you have a feedback signal. So desired state is what you want, and feedback signal is what you have actually at the field. And the error of that two guys is actually there's a deviation. How much is the deviation of what you want and what actually you have? That's error. So error is going to actually decide how much should be the control signal that should fit into the system, what we call it control valve, to regulate or to meet the set point requirement. That's all for today. In next session, we are going to talk about how to tune a PID loop. What are PID terms? Thanks for watching this video. Till next video, take care and Allah Hafiz.